We'll go with my favorite student, good old Anne. What's the definition of a force? I think I said this. A force is a push or a pull. That's one. Did anybody say anything else? Yeah. I'll take that. That's not really the definition of a force. That's more the symbol for a force, but okay. Anybody say anything else? Yeah. Oh, sure, I'll take that. Did you find that from somewhere online, Googling or something? Yeah, because I've never used that phrase. That's that whole action-reaction phrase that I hate, but yeah. So again, what's an action? I mean, in movies they say, action! I don't think that's what we're talking about here. Really, it's that which causes mass to accelerate, if you really want a good definition. Oh, and if the mass is not accelerating, then there's not an unbalanced force. I would take that. The one that I won't be that I will be fussy on, what's the units of force? Newtons, or if you just wrote M, that's fine. If you wrote kilogram meters per second squared, I'll take that because that's really what a Newton is, because it's mass times acceleration, but okay. So 1 mark for each of those. 1 mark, 1 mark. Key word in number 2, what net force? As soon as they talk about net force, what I'm really thinking is that F net equals ma, and they want the net force. Did they give me a mass? Yep. Did they give me an acceleration? Yep. 2,400 newtons. Now, if you want to ask Matt, which force is that? It's friction from the tires. So friction from the tires would need to be 2,400 newtons at least if you want to accelerate that car at 2 meters per second squared. By the way, if you are accelerating a race car at 2 meters per second squared, you're losing the race. 2 is not very big. Number 3. Oh, is number 3 worth more than 1 mark? Probably means it's multi-step. Says, what is the force on the shell? Well, F equals ma. Cohen, did they give me the mass? Yeah. Did they give me the acceleration? They did?
No, they gave you final velocity.
In fact, there's a hint. What's the hint?
Rest.
No, there's a hint. What's the hint?
Find the acceleration of the shell first.
Did they give me the acceleration? Nope, I'm going to have to find it. So I'm going to go like this. A equals question mark. I drew a little line down my page. What else did they tell me? They did give me V final. You know what? Cohen, for any artillery shell or gun or cannon, I know V initial. What's VI for anything that we fire?
0.
Yeah. Is that reasonable to ask you to know that? I think so. And what else did they tell me? Oh, D is 1.5. Negative 1.5. I think we're going forwards. I think we can assume D is positive. So I'm looking for an equation that has A, VF, VI, and D in it. There is one, this one here. VF squared equals VI squared plus 2AD. And if I get the A by itself, I'm going to get VF squared drops down like a domino. I would minus the VI squared over, and I would divide by the 2D. It's going to be 770 squared minus 0 squared all over 2 times 1.4. Cohen, an artillery shell, do you think that would have a big acceleration or a small acceleration? I think a really big. I'm expecting a big answer here. I'm not going to freak out if I get a big answer here. So I get, oh, there's more than one number on the top brackets, 770 squared minus 0 squared. Probably, Connor, I didn't need to type the 0 squared, but I'll stick it in there anyways just so you can see the, thought of it. Divided by more than one thing on the bottom. Or, Matt, I could have just gone 2 times 1.5 is 3. I don't mind being a little lazy. Anyways, no, it's an artillery shell. They should have a massive acceleration. I'm okay with that. So I'm going to write down 197633.3, and that's an acceleration. And I'm going to take it, stick it over here. F equals M 65. A, 19763.3. Although I'm going to use my answer button. So I'm going to go 65 times answer button. And I get a, wow, big force. I'm going to go, you know what? This time I am going to go, yeah, am I wrong?
No.
Oh.
For the, instead of doing dx squared, I forgot the squared and did the square root. Would that be wrong?
Yeah, I'll come and look at yours in this. But yeah, well, you would have got a different answer, right? So yeah, it would be wrong. And yeah, why don't you square, look, is there a squared on the A? See, if there was a squared on the A, that's when you would need to square root to get rid of the squared on the A, because that's what we're trying to get by itself. So later on, after we finish the whole quiz, and I say, come lawyer with me, show me, and I'll see what I'll give you for part marks, okay? Is that all right?
But doesn't, like, 197,000
Yeah.
per second a bit fast?
No, it's an artillery shell. Please believe it goes fast.
But is it from a gun?
Huh?
Is it from a gun?
It says it's an artillery shell.
Fire from a gun.
Yeah, what's the weight of an artillery shell? So it's not a bullet.
Oh.
It's got to be it's a gun. It's a big cannon. It's something. By the way, how long is the barrel?
No.
No, how long is the barrel?
1.5 meters.
1.5 meters. You know what? This is one of those old style artillery cannons. So if you're fixating on the word gun, I can change that word next year, but I'm telling you, it's an artillery shell. They accelerate really fast, which is why you need so much gunpowder to apply such a big force to get them to accelerate really fast. Because we're going to get F equals, I'm going to go scientific notation, 1.28 times 10 to the, because this is big enough that it's worth 1, 2, 3, 4, 5, 6, 7, I think. And it's a force. What do I measure force in? Newtons. In terms of part marks, I would probably do something like this. If I saw that, that would get you a half mark. If I saw that, that would get you a half mark. If I saw that you would clued in that we needed to find the acceleration, that would get you a half mark. I would give you a half mark for that equation. I would give you a half mark if I saw that, and I would give you a half mark for the acceleration. So, coming back to you, sir. You probably wrote this somewhere, okay? And if you took your wrong acceleration and you times it and got an answer, the only place I would ding you a half mark for this, and for this I would give you 2 out of 3. Okay? 1, 2, 3, 4, 5, 6. Yeah, that works. Courtney, how many marks is number 4 worth? Probably meant to be easier. Oh, and what's the word in front of the word force? Net. Oh, you know what? I can go straight to just saying net force is MA. Except, what do they want me to find in this question? Yeah, all magnitude means is answer, or so what do you want me to find? The answer of the answer? No, the magnitude of the acceleration. How would I get the A by itself, kiddo? Yep. Double check. Did they give me a force in newtons? Did they give me a mass in kilograms? Well, here we go. Oh, you know what? I can do 12 divided by 1.2. 10, yes? Got to be 10 even. I'll put a dot to go to 2 sig figs. I'm not going to be that fussy, but 1 sig fig always irks me. Meters per second squared. But yeah, 10. 1 mark. Okay. The 1 markers, I'm usually kind of an all or nothing person on these. Next page. Okay. Number 5. Prith, what do they want me to find in number 5, part A? Acceleration. By the way, the reason I put average acceleration, that's me hedging my bets and being fussy, Sarah, saying I'm not sure the acceleration is constant. In fact, I don't think it is for a rocket ship, because as you burn up fuel, you got less mass. I think it'll speed up. Whatever. Average. So I'm going to do this. Well, don't write this down. I might be tempted, Courtney, to do this again. But what did F stand for, Prith? What do they want me to find in part B? Force. You know what? I'll bet you that's not going to work because otherwise they wouldn't bother asking part B. How else can I find acceleration? Oh, lots of ways. Let's defic. I see from rest, VI is 0. VF is 3.2 times 10 to the 4th. T equals 32. Hey, I have an equation that has A, VI, VF, and T. In fact, I'm so good at that one, I might even go straight to the equation. I think it's going to be the VF drops down like a domino. We would minus the VI over and divide by the T. That was what we used all the time, yeah? 3.2 times 10 to the 4th minus 0 divided by 32. This is going to work out evenly as well. Well, that's kind of nice of me. And I get an acceleration of 1,000 meters per second squared. Okay. Here, I'd probably go half mark, half mark. By the way, this is a rocket engine. I can tell you right now, this would have to be an unmanned probe because humans would not be happy right now. 1,000 meters per second square, that's about 100 Gs. You're not surviving it. So this would be like, in fact, but I think the one that they launched to Pluto had a G-force something nearly this. Maybe not, because this is also hard on materials. I might have made up bad numbers. Prith, what does part B want me to find?
FNet.
Oh, you know what? FNet is just MA. Did they tell me the mass? Hey, they did. 4.5 times 10 to the 4th. Did they tell me the acceleration? I just calculated it. I think you get 4.5 times 10 to the 7th newtons. Timesing by 1,000, you just add an extra 3 to the power of 10, right? I guess I'd give you a half mark and a half mark. Trevor, same as before, if you got the wrong acceleration, but you dropped it down there and you multiplied it by 4.5 times 10 to the 4th and got that answer, a different answer, but did it correctly, I give you 1 out of 1 for part B. Also, hopefully you've clued in, never leave stuff blank. If you can't get a part A on a test, make up a reasonable answer for part A, drop it down to part B, write me a note, I'll figure it out and I'll crunch it on my calculator and give you full marks for it. A net force of 1.6 newtons east acts upon a 6.4 kilogram object. If this object accelerates uniformly from D equals question mark. 2 marks suggest this might be multi-step. Well, I know V final equals 12. V initial equals 0 from rest. You know what? If I knew A, I'm good. Because then I could go like this. G equals VF squared minus VI squared all over 2A. I used VF squared equals VI squared plus 2AD and rewrote it. Wait. A also equals force divided by mass. Courtney's equation. Courtney, did they give me a force in newtons in this question? Is it a net force so that I know I can go straight to F equals M? Well, that's nice. Did they give me a mass? Oh, sheesh. 1.6 divided by 6.4, 0.25. Is it 0.25 meters per second squared? Should be, yeah. Wow, I was making numbers work out nice for a change. I normally don't care about you guys enough to do that. That wasn't a joke. Oh, okay, yeah, sure, it was, yeah. Now, plug it over there. So it's going to be 12 squared minus 0 squared all over 2 times 0.25. You know what? I think I can do this in my head because 12 squared is 144. 2 times 0.25 is 0.5. Dividing by 0.5 is the same as timesing by 2. 288 meters, yeah? Yeah? So if you got that, 2 out of 2. Otherwise, I'd probably do something like this. I'd give you a half mark if I saw that equation. I'd give you a half mark if I saw that. I'd give you a half mark for finding the acceleration, and then a half mark for plugging the acceleration in successfully. How much time did it take to travel the distance in part A? You know what? I think I can go like this. T equals VF minus VI over A. There's other ways I could find T as well, but I think that'll get me there the cleanest. Because it's going to be 12 minus 0 all over 0.25. Is it 48 seconds? I don't know why I made that one worth 2 marks. But I guess I did. How about 1 whole mark for that? Half mark for the numbers, half mark for the answer. Again, if you got the wrong acceleration here, but you dropped it down here successfully, I would give you 2 out of 2. If you went 12 minus 0 divided by whatever you got for your acceleration. Oh, and I guess we turn the page. Last page. Here we go. A book is sitting on a level desk. Hey, your binders. Which of the following statements are true? There are no forces acting on the book because it's not accelerating. True or false? False. There are forces acting on it. It's just that they're balanced. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. Why is that true? Is it sinking into the ground like quicksand? Is it flying in the air like Superman? Okay. The net force on the book is equal to 0. Why is that true? That's what Newton's first law says. Is your binder accelerating? No? Well, then the net force is 0. Friction force is what's holding the book on the desk. If your desks were made of ice, would your books still stay on there as long as your desks were level? Yeah. So is friction what's holding your book on the desk? Don't think so. By the way, you see how I reasoned my way to the answers for all these? Okay. So FTTF, you know what? Half mark for each one. Oh yeah, because it's out of 2, 4, yeah, half mark for each one. Elevators. They want me to find the scale reading. No, they don't. Well, yes, they do, Mr. Duke. Not really. When they say find the scale reading, what are they really asking me to find here? Normal force. Okay? That's worth committing to memory, because I guarantee there's going to be elevator questions on your test. Or I might even change it. I might even try and work that OK Go video, because that's an elevator in disguise, just with no cable, but it's a jet plane, and that's way cooler. So anyways, gravity down. We're accelerating up, so I know the normal force must be larger. In fact, it's the scale that's pushing this person up. You going to make it, Alex? That was a bit of a shaking me to wake me there. Yes? Who's winning? Normal force. Oop, not equals. Who's losing? Gravity. That equals ma. I think the normal force is going to be ma plus mg. The normal force is going to be m60. A 1.2 plus 60 times 9.8. I can do this in my head, because this is really the same as 60 times 11. 660 newtons. If you got the right answer, 2 out of 2. Otherwise, I would give you a half mark for the free body diagram, a half mark for that equation, a half mark for getting the Fn by itself, and a half mark for the answer. Which means if you got the wrong answer and you didn't draw a free body diagram, you lose a half mark for not drawing a free body diagram, because it's a handy-dandy little tool. Accelerates downwards. Well, what are the forces acting on this person? We got gravity down. There's a normal force up, but I know the normal force is smaller because downwards is winning. In fact, my equation is going to look like this. Gravity minus the normal force equals ma. I'm going to plus this over and minus that over at the same time. I'm going to get the gravity dropping down like a domino minus ma. That equals the normal force. The normal force is going to end up being m60 times 9.8 minus 60 times 2.25. Why'd I go to 3 decimals there? Okay. Let's wimp out. I'm not going to try this one in my head. 60 times 9.8 minus 60 times 2.25. Did y'all get 453 even? Well, that's kind of nice. 453 what? It's a force, newtons. Same marking scheme as before. If you got the right answer, 2 out of 2. Otherwise, I'd give you a half mark for that, a half mark for that, a half mark for getting a normal force by itself, and a half mark for the correct answer. Part C. What's the key phrase in Part C? What's that really telling me? If you want to, you can realize it's going to be gravity equals the normal force. There's no acceleration. Now, if you wanted to prove that, you would say, here's my free body diagram, get the obvious one, gravity, normal force. You might say, well, it's moving up, Mr. Dewick, so maybe normal force is bigger, I'm not sure, and you would go, okay, normal force minus mg, but you would still say cone equals 0, because what's your acceleration? 0. And can you see if you plus the mg over, you do get normal force equals mg. You get the normal force is going to be 60 times 9.8. 60 times 10 is 600 minus 12. 588? No, yes? Yeah? Newtons. Again, if you got the right answer, 2 out of 2. Otherwise, I would probably this time give you 1 whole mark for seeing that and 1 mark for the answer. What if the elevator is in free fall? What would the scale read? If you went straight to saying, hey, Mr. Dewick, I'll take that. We did a proof in our notes, but you can find if you go make the normal force really small, as if it's and solve for Fn, you do get 0, because you'll get 60 times 9.8 minus 60 times 9.8. You get apparent weightlessness. I guess 2 marks just for that. Can you give yourself a lovely score out of, count 'em, 23? And now is the time to come lawyer with me.